So hi, whoever's watching this, good morning or good afternoon whenever you're watching this. Today I'll be presenting our findings from Lab 3, which are focused on shear testing of metallic samples. The goal was to explore how materials behave under shear stress, compare measurement methods, and understand the limitations of different testing approaches. Let's get started. Let me pull up the PowerPoint. Mhm. All right, hopefully you can all see that. Right. So, um, the objectives of the experiment were threefold. First was to perform shear testing on two metallic samples. They were copper and stainless steel. And then using both displacement-derived strain and GOM image-based strain tracking. And then second was to calculate and compare the shear modulus using multiple approaches. And then finally to identify the sources of error and evaluate how different methods can complement each other in material testing. I'll go over the methodology real quick. Um, in terms of methodology, we prepared specimens according to the test requirements and mounted them in the shear testing fixture. For each sample, we collected data in two ways mainly. So first of all, we used the displacement recorded by the testing machine to calculate strain, and then we used GOM correlate, which tracks strain through digital image correlation. This allowed us to directly compare mechanical and optical measurement techniques. Uh, let's go to the next slide. All right, the graphs on this slide basically show the shear stress versus shear strain for both the displacement derived and GOM derived strain. On the y-axis, we have shear stress. On the x, we have strain, as usual. Both methods reveal the elastic region clearly, but differences become noticeable beyond the proportional limit. I think these differences likely result from the resolution and sensitivity of the equipment, as well as alignment challenges because everything was shaky and all over the place, honestly. And then the graph helps us usually visualize material stiffness and how each measurement technique helps capture deformation. Let's go to the fifth slide. So, unfortunately, there was supposed to be a bar chart here, but at the time of filming this video, I can't seem to find it anywhere on my computer, and it's too late now to make one. So let's just imagine there's a bar chart there. So basically, the bar chart would have force and displacement, force and the GOM strain, and then using Young's modulus and Poisson's ratio, it'd be all there. And then for copper, we were able to get all four values. For stainless steel, tensile data was unavailable when I did research, so only three values could be compared. The closeness of the copper values suggests high consistency, while the spread in stainless steel values um, highlights the importance of having complete material data for accurate comparison. Um, let's go to the sixth slide. Yeah, discussion and error analysis. Okay. So you might be asking yourself, why do the values differ? Some causes include limitations in equipment. There might be small calibration errors here and there. And then, of course, like I said, misalignment issues. It was very hard to set up. It was very shaky. And then after setup, sometimes the samples got misaligned. Um, In our group, specific issues such as delayed image capture and inconsistent sample markings added an extra layer of variability. So basically, this reinforces the idea that no single method is flawless. Cross-checking results helps improve confidence and, identify ways to make it better and, identify anomalies. And then, lastly, to conclude, the GeoM Correlate offers a valuable optical measurement method that complements traditional displacement-based strain calculations. For copper, results across all methods were consistent, but stainless steel showed greater variance due to missing tensile reference data because I wasn't able to get it. This lab mainly, I think, emphasized on the importance of precise synchronization between image capture and force measurement, and it suggests that automation or higher frame rates could potentially improve accuracy. Um, Overall, this experiment reinforced the value of using multiple measurement techniques to strengthen the reliability of the data. Um, but yeah, I guess besides that, everything's good. So, yeah, hopefully that should cover it. So, hope you have a good day.